All right, good morning, everybody. Time for something extremely important and a little bit different from what we've been doing before. Get ready for lesson 74. We are all about units of length today. So there's lots of different ways to measure how long something is or how wide something is. And at the top of page 480, they give you a handy dandy little chart that should solve most of your problems. You will be turning back to this page a lot from here on out until you get these numbers memorized. On the US customary system, that's what we use in America, you have 12 inches equaling a foot. Most fifth graders know that. 3 feet equaling 1 yard. Where it gets a little bit trickier, 5,280 feet equaling a mile, and 1,760 yards also equaling a mile. Over here on the metric side, you have 10 millimeters equaling 1 centimeter. We've covered that already. There's 1,000 millimeters in 1 meter, or 100 centimeters in a meter, or 1,000 meters in 1 kilometer, or kilometer you sometimes might hear it called. And they tell you that a meter is about 3 inches longer than a yard, and a yard is 3 feet. My football players out there should know that. That game is all about the yards, right? Again, I cannot stress enough, turning back to page 480 is the key to solving these problems. So let's jump right into it here. One player on the team is 197 centimeters tall, and they want to know how many meters tall is he. So what do we know about centimeters to meters? Looking on our chart here, it says 100 centimeters equals 1 whole meter. So I could take that 100 right there and call it 1 whole meter, right? So what do I have left? 97 centimeters. So I'd have to write it as a decimal number. 1 and 9/10 and 7/100. 1 and 97 hundredths of a meter, because hundredths are centimeters. There are 100 years in a century, right? Or 100 cents in $1. Check out this guy. 2 yards is how many inches? And the first thing fifth graders usually do is go down to the handy dandy chart and they say, it doesn't say how many inches there are. So you're going to have to do one extra step. All they tell you about yards is how many feet there are, right? So first, I'm going to have to go and get 2 yards converted into how many feet? Well, how many feet are in a yard? Looks to me like it says 3 here. So 2 groups of 3. Do you see how we're doing this? 2 times 3 is 6. If you got 2 yards, you have 6 feet. So now let's go and convert the rest of the way. From 6 feet is how many inches? Well, how many inches are in a foot? Over here it says 12. So you have 6 groups of 12. I could go 12 plus 12 plus 12 plus 12 plus 12 plus 12 plus 12. I could go ahead and add it 6 times, couldn't I? But that would be kind of silly. Why wouldn't we just go ahead and multiply that out? 12 inches in a foot, and I have 6 of them. Hopefully you know that would be 72 inches then, right? Just because it's not listed out on your chart, sometimes you might have to put in an extra step. Check out this guy. How many yards are in 1/4 of a mile? So let's see what our handy dandy chart has to say about yards and miles. Here it says there's 1,760 yards, right? So I got to think about 1/4 of 1,760. And 1/4 just looks like this, right? If I use the numbers. So what have we been saying for a long time? If the numerator is 1, divide by the denominator, right? So this is just going to turn into a dividing problem. I'm going to have to go 1,760, and I'm going to divide it by a divisor of 4, right? So let's go on and get to it. 4 is going to go and divide into 17. Looks to me like 4 whole times, right? Multiply that guy back for 16. He's going to subtract 1. I'm going to bring down my next number here. And 16 divided by 4 looks like he goes in there 4 whole times. Multiply him back for 16, and he's going to go ahead and subtract for 0, right? So my answer is 44. No way. I still have one more quotient digit. I have to get on top of that 0, right? How many times does 4 divide into 0? Hopefully you know. 0 times. Multiplies back for 0. And he's finally going to subtract 0. So, how many yards are in 1/4 of a mile? 1/4 of 1,760? Your answer would be 440 yards, right? Check out this guy. 50 millimeters is how many centimeters? Well, right here it says 10 millimeters equals 1 centimeter. So how many groups of 10 can go in a 50? Basically another dividing problem, right? If you're not sure how many groups of 10 can you put into 50? Does it make any more sense now? That would be 5, right? So 50 millimeters is 5 centimeters. We've done that before in another lesson, remember, where you just have to bring the decimal point over one spot to the left. One more here. A 10K race really means a 10-kilometer race. And they're asking us how many meters are there in 10 kilometers. So what do we have over here? We know that there's 1,000 meters in 1 kilometer, right? So let's start off here. We know that there's 1,000 meters because there's 1,000 years in a millennium, right? That prefix milli means 1,000. So 10 groups of 1,000. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. Can we do it? Hopefully we can. It is 10,000 meters then, right? 1,000 times 10 is going to give you 10,000 meters. So now for something a little bit different, they're going to go and review median, mode, and range with you again. So I see some people still kind of struggling with some of these words, so let's run through them real quick again. Median, that's the number in the middle of your data set when they are arranged from least to greatest. And I was helping out a guy the other day, and he was starting to lay out the data right now. Like first he'd go 10. But the big mistake, then he wrote down 11 and 12. Do you have any X's right here representing those numbers? No, you don't. The next number in your data set is 13, and you have two of those, right? So I'm going to go 13 and then 13. Next one I have is a pair of 14, so I'll go 14 and then 14. Looks to me like I have 4 15s, so let's do that. 15, 15, 15, 15. Then I'm going to have 2 16s, so 16 and another 16. Then I'm going to have 3 17s, so 17, 17, and 17. I don't have any 18s, and now I have a 19, right? So that was the big mistake I saw when people were trying to arrange data sets. Now we're going to go and look for the number in the middle. First of all, if it's an odd number, it's really easy to find. If it's an even amount we have in our data set, then you got to look for the middle of the two. So let's count. How many numbers do we have in this data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, half of 15 is 7.5, right? So if I put 7 numbers right here, 1, 2, 3, 4, 5, 6, 7 right here, and then I go to the other side and I do another 7, I will go and find out that my one number I have in the middle, my median, is 15, right? You only write down the numbers that you actually have, not all the numbers that are listed. Let's check out this one, the range of this data set. The range, most people have a pretty good handle on. It's the difference, meaning you subtract the highest and lowest number in the data set. So my highest number I have is 20. My lowest number I have is 10. What's 20 minus 10? The highest number I have is 20. The lowest number I have is 10. And difference means we subtract. So hopefully you know 20 minus 10, that's 10. So the range equals 10. Check out this guy. What is the mode of this data set? The number that occurs most often. And when it's all set out on a line plot for you, it's pretty easy to see the mode has to be 15. That's the one that's happening most often. But one more here for you, because what would be the mode of this data set? What number is occurring most often? I don't have one. I have a whole bunch of 2s. 2 is not the mode. If you don't have one number that sticks out more than the rest, then you would simply go and write, there is no mode. All right, that is the end. I cannot stress enough. You will want to have your book opened up to the top of page 480. You're also going to want to scratch a piece of paper. Good luck on the Socrative quiz, and